Hey everyone, hope you all are doing good. Good morning, good afternoon, and good evening to all who all are joining us globally. I am Parth Varu, UN Program Manager for Microsoft Reactor India, and I welcome you all to our show Tech Espresso. But before we begin, let's go through our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding our differences, being kind, and considerate in a way you all engage. Yes, obviously, we do encourage you all to participate. Please drop all your questions in the chat section. Now, I would like to welcome Dixit, who is the speaker for our session. Hey, hi Dixit, how are you doing?
Hey, good morning, Path. All good, Path. Thanks for asking. How about you?
I am all good. I am at Reactor today.
Same goes for me.
So, what do we have today, Dixit?
So, Path, today we are going to discuss about the KEDA and the DAPR introductions, how to use it in the AKS and the brief concepts about that.
Cool, Dixit. So, the floor is all yours. Let's start with share your presentation.
Sure, sure. So before going to the presentation, just a brief intro about me. Hi everyone, this is Dixit Arora, working in the Microsoft as the senior customer engineer. Been in Microsoft from the last couple of years, and today we are going to discuss about uh, the KEDA and the various use cases, why we are using it, and the introductions of the DAPR extension in the AKS, and what are the various use cases that we have. Okay, then let me switch over to sharing the presentation. Path, is it visible?
Yep, we can see the screen.
Hey Path, are you able to uh, see the deck?
Yep, we can see the screen. Yeah,
Sure. Shall we start or?
yeah, we can start. Yep.
Great, great. Sure. Thank you. So guys, let's start. So today we are going to discuss about the KEDA and the DAPR extensions introductions in the AKS. It is going to be uh, the introduction sections that we are going to cover. It is not the you can say a uh, deep discussion on these topics, because what we thought that we will start from the basics, because these are new topics, and uh, when we worked with customers across the globe, so many customers are not aware that how they can make it use of these things in the AKS and what are the use cases. So we thought that we will start from the beginning, or let's say from the scratch, and then move towards the go deeper into these particular topics. So KEDA. So what is KEDA? Obviously, it is the Kubernetes event-driven auto scaling. Uh, in this, we are going to discuss about uh, the various concepts regarding the KEDA that we have, how you can deploy the KEDA, and a brief about the architecture of the KEDA and the various use cases in the KEDA and the AKS. So first of all, before going to discuss about uh, KEDA and what are the various use cases that we have. In the last session that we have done in the reactors series, we touch upon uh, the various best practices and the architectural techniques that we can use to deploy the AKS baseline clusters in the prod environment. So on those lines, just wanted to have those uh, things regarding the scaling options that we have available in the AKS, so that when we start discussing about the KEDA, we will have the basic overview, or the basic understanding that why we need KEDA, what is the need of inventing KEDA, and then start using from the various use cases that is not available, or that has not been met by the scaling options that are already available in the AKS. So in the AKS, we have uh, couple of options available to scale the application or to scale the pods or to scale the cluster nodes that we have. So various options in the AKS that we have is the horizontal pod autoscaler, the cluster autoscaler, uh, the manual scaling, and the vertical pod autoscalers. So the vertical pod autoscalers is currently in preview, but the rest three is been used widely by the customers in many of their business use cases. So moving to the horizontal pod autoscaler. So in the horizontal pod autoscaler, basically it uses the metric servers in the Kubernetes cluster to monitor the resource demands of the pods. So that if an application need more resources, the number of pods is automatically increased to meet the demand. So basically, the horizontal pod autoscaler will be responsible uh, to scale out the pods on which the in which we have deployed the application, so that if the application need more resources, the number of pods is automatically scaled out. So to to s- to scale out the number of pods, we do have the horizontal pod autoscalers, and the horizontal pod autoscalers is only responsible to scale out the number of pods. It is not responsible to scale out the number of nodes that we are running in the AKS. So if we have the requirement, or if we are looking to scale out the number of nodes, then do we have the option of we do have the option of cluster autoscaler. Now, what exactly is the cluster autoscaler? Cluster autoscaler will keep looking for the pods that can't be scheduled on nodes because of resource constraint. So that let's say we are running the applications, and let's say there are certain number of pods that are running on let's say two nodes or three nodes. But let's say due to certain search, or due to certain you can say the specific resources that we're utilizing, it need more underlying resource, so that more pods can be scheduled on the nodes. But due to the resource constraint, those pods can't be scheduled on a nodes. So under that particular use cases, the cluster autoscale will come into the picture, and it is responsible for automatically increasing the nodes. So the cluster autoscale will take care of scaling out the nodes in the AKS, and the horizontal pod autoscaler will be responsible for scaling out the pods in the AKS. The third option that we have is the manual scaling. As the name suggests, it is not the certain automatic configuration that will be able to achieve. It is the manual effort uh, from the developer, from the DevOps guy, or let's say from anybody who is interacting with the AKS, so that they will be able to manually specify the number of pods that you are looking for, or manually specifying the number of nodes in the AKS cluster that you are looking for. So it is the manual intervention that is needed, and you specifically uh, specify or telling the AKS cluster that these are the nodes I'm looking for, and these are the pods I'm looking for. The fourth option that we have is the vertical pod autoscaler. Currently it is in preview, but it makes you what it does, it basically it analyze the processor and the memory resources to right size your applications, uh, so that the application on which pods are running, it have the right processor and the memory resources which the pods is looking for. So the vertical pod autoscaler is also not responsible for scaling up, but is also responsible for scaling down based on the resources. And even coming again to the horizontal and the cluster autoscale. So both the horizontal and the pod autoscale can also decrease the number of pods and the nodes in the AKS clusters. Uh, the cluster autoscale also decrease the number of nodes when there has been unused capacity for over the you can say over a certain period of time. And when that particular things happen, the the pods running on that particular node can also be removed by the clusters autoscale, so that they can be scheduled safely on the other nodes that are running in the clusters. So as of now, we have discussed about various scaling options available as a part of AKS. the horizontal pod autoscaler, the cluster autoscaler, the manual scaling, the vertical pod autoscalers. As we have mentioned, it is in preview. Now I will just take a pause before going on to the KEDA, that if there are any questions or any doubts anybody is having in all these four options that we have discussed. Any questions from anybody? Okay, let's move forward. So uh, as we discussed that uh, the scaling options, scaling out the number of pods, the scaling out the number of nodes, and the most important part, what what all four options that we have discussed in the previous slide, all these scaling options taken into account the CPU and the memory matrix of the Kubernetes underlying compute. So whenever we are defining that, either we are looking to scale out the number of pods or to scale out the number of nodes that we are running. So the metrics that we are using on all these four scenarios, or let's say on all these three scenarios, leaving only the manual scaling part, will be the CPU and the memory. Now let's say you as a business case, as a requirement side, as a requirement, I do have the requirement that I need to scale out either the pods or either the number of nodes, um, depending upon, not on the basis of CPU or memory, but on the basis of certain events happening in the external source. So let's say there are some messages uh, uh, in the queue. There are certain events needs to be there are certain events that are available, or messages available in the Kafka. So if I need to scale out on the basis of those events that are present in the external source, here it comes the concept of KEDA. So KEDA stands for Kubernetes Event Driven Autoscaling. It is the initiative started by the Microsoft and the Red Hat initially, and then the Astronomer and the Cordit are the also the large contributors in this particular project. But after a while, this has been donated as a sandbox project to the Cloud Native Computing Foundation, and from there onward, it is open to you can say uh, any contributions from the Cloud Native Computing Foundation's community members, or anybody who wants to contribute it. So basically, when we say KEDA, as we discuss regarding uh, that, if we want to leave the CPU and the memory matrix and want to have the uh, scaling options available on certain events that are happening in the external source, we need to use the KEDA, the Kubernetes Event Driven Autoscaling. So KEDA can run both on the cloud and obviously on the edge. Uh, and one of the basic fundamental principle is that uh, for the understanding, we can think of that it is built on the top of you can say the horizontal pod autoscaler. And in a while we will also discuss about the brief intro, or let's say the brief architecture of the how KEDA works, and what are the various components that are the main components that fall into the KEDA, that will make us uh, work on the scaling out options on the basis of events that are available in the external sources. So what are the various features of the KEDA is, as we mentioned, that it is event driven. So let's say there are 5 messages in the Kafka, there are 5 messages in the storage queue, and on the basis of those messages or the events that are falling into the Kafka service bus, or the storage queue, you want to scale out the pods that are running into the AKS clusters. So we can use the KEDA in the AKS. So it is event driven. Obviously, the auto scaling made simple, as initially we discussed that regarding the HPA, that we have the uh, the vertical pod autoscaler, or the cluster autoscalers. So all those scaling options are only working with respect to the uh, or let's say mostly working with respect to the CPU and the memory metrics that we have. But if we want to go beyond that, then KEDA is the options. The third is the built-in scalars. So scalar is basically the source, the external source from which the KEDA will be interacting, and KEDA will be uh, taking those events, and on the basis of that, it will pass the respective information to the horizontal pod autoscaler, and so that it can scale out the applications running into the AKS cluster. Also, so that it can scale out the number of pods running into the AKS clusters. So it has the when we say scalars, so obviously there are many scalars available, and it is not specific uh, to the Azure offerings that we have. It is much more than that. We do have the scalars available for the other cloud providers as well, for the other Azure services, as for the other cloud services as well. For example, certain services from the AWS, certain services from the GCP as well. So it is not you can say uh, vendor lock-in when we work with KEDA, and it has the scalars available for all the uh, other cloud providers as well, and other and also for the open source uh, services that we have. So in that particular way, we have the vendor agnostic uh, option available, as when you start leveraging KEDA, and when you start uh, taking the scaling out option based on the events in the external resources. The external source can be anything, either the service from the Azure side, either the service from the open source, either the service from the AWS, or either the service from the GCP. So in that particular way, it is also the vendor agnostic that we have. And also we do have the support uh, for the Azure functions as well. So again, uh, I will take a pause here, and we'll look out if there are any further questions, or any questions from anybody at this particular stage.
Hey Dixit, so we have a question from Prasad. I'd like to bring it up on screen.
Uh, Path, can you please call out, or let me.
Is KEDA mainly sustainable only for event based? For example, Azure function triggered from storage queue, or can we have executed batch jobs which are executed on CRON cron?
Is KEDA mainly suitable only for event based? For example, can we have executed batch jobs which are executed based on cron? So Prasad, for the cron thing, obviously you can have the the so the basic intention is that if you want to have something on the timing base, obviously you will be able to do it by the Azure function as well. And even we do have the slide that when we have the KEDA, why uh, then what is the parallel execution, or the parallel implementation of the Azure functions. So let's say I do have certain requirements that can fall only as a part of Azure functions. So obviously under those circumstances, you can also leverage the Azure functions. But if that particular requirement is coming as a part of, or can be fulfilled by the KEDA scalars that we have, then obviously you can go with the KEDA. But we do have the slides uh, upcoming deck that will also compare that what is the need of uh, you can say KEDA when we have the Azure functions. So Prasad, I hope I answer your questions, but please do let us know if there are any further questions.
Shit, we have one more question coming in.
Sure, please.
What is the specific use of KEDA other than it being event driven? That is, which uses case, which use case is it targeting in an application?
Got it. So let me open one more thing, and if I write data, so we do have the scale is available. So obviously, the most use cases of using KEDA and the scale is available is for the event driven. But when we say event driven, when we talked about the scalars options in the KEDA, so as you can see that we have many you can say external sources on which you will be able to do the integrations, and based on those integrations, based on those events, we will be able to scale out the pods in the AKS clusters. So it is uh, obviously, let's say event driven is one thing, and also there are certain scalables, certain you can say scalars which are currently in preview. For example, if you want to scale out the number of pods based on the HTTP request that you're making, even those things are in progress. So it is not only the event based, but also for the HTTP request that we, for example, in the case of HTTP trigger, in the case of Azure function. So we do have uh, those scalars built in, or scalars are being working upon on those business use cases also, which is different from the event driven, but also taking the HTTP request from the application standpoint of view. And when we talked about various scalars option availables, as you can see that we have the, let's say, as of now it is showing the for example, for the AWS services. So these are the AWS services that if you want to integrate and if you want to handle any such events based on these AWS services, you will be able to scale out the pods running into the Kubernetes clusters. Then it comes the Azure services that we have, for example, blob storage, data explorer, log analytics, the events up that we have, the Azure pipelines that we have, any messages that land into the Azure service bus. Then comes to the open source community Cassandra. Even the cron thing is also available. So it is not limited only to the event base, but also, as you mentioned regarding the timer based thing, the cron thing, and also to the HTTP based uh, request also. Any further questions from anybody?
Yeah, one more question from Sunil. Can KEDA help with vertical auto scaling as well?
So for the vertical autoscaler, we do have the vertical autoscaler coming into the AKS itself, but currently it is in preview. It is not GA. It is in preview. So let me give you the vertical pod autoscaler in the Kubernetes. If you see this, these are the vertical pod autoscaler option is coming into the AKS itself, but currently it is in preview. Any further questions from anybody before moving forward?
Dixit, no, we have Vivek Sridhar also joined us on a stream, and he has been helping answer the questions as well.
Okay, great. Hey Vivek, thanks.
Yeah, we can go ahead. I see no questions coming in.
Okay, sure. So moving forward, so what is the architecture that we have that is helping in the event driven uh, event driven auto scaling in the Kubernetes clusters? So this is the KEDA architecture that we have. So basically it has two main components. One is the KEDA operator, and other one is the metric server. So in the case of KEDA operator, what it uh, basically it allows end users to scale the workloads in and out from 0 to n instances, with the support of Kubernetes deployment jobs, or let's say any custom resource that define the scale sub resources. And the other important component that we have in the case of KEDA is the metric server. So basically, in the case of metric server, it exposes external metrics to the horizontal pod autoscalers in the Kubernetes for autoscaling purposes. For example, as we have discussed, a message in a Kafka topic, or the number of events in the case of Azure event, and in the case of Azure Event Hub. So basically, as we have already discussed, you can think of the KEDA built on the top of horizontal pod autoscaler, and the KEDA will interact with the external resources, or the sources that we have in the form of scalars, so that it will translate that particular uh, uh, integration, or the trigger, to the horizontal pod autoscaler, which horizontal pod autoscalers can understand. And on the basis of those events, it can be the in the message of, you can say, timer based trigger. It can be the uh, uh, on the basis of certain message in a let's say uh, service bus, or it can be the number of events in the case of Azure Event Hubs, or it can be the message in a base of in a Kafka topic. So you will be able to scale out the number of pods running into the Kubernetes clusters. Moving on, uh, so we discussed that how KEDA works, and one of um, the difference that we have with respect to the KEDA and to the other horizontal pod autoscaler that we have, that in the case of horizontal pod autoscaler, I believe up to the Kubernetes version 1.26, uh, you will not be able to scale down the to the zeroth level, but KEDA will by the use of KEDA you will be able to do it. So let's say if there are no messages uh, in the Kafka topic, of there is no messages into the service bus, there are no events into the Azure Event Hub, you can literally scale down to the zeroth level. And when there are message or events available in those Azure or Kafka topics, you will be able to scale it from 0 to n, and again from n to 0. But those things are not available to the certain Kubernetes version in the case of horizontal pod autoscaler. So this particular slide talked about that how KEDA works. As we discussed that in the case of KEDA, we do have the metric server. So KEDA will expose those external services to the horizontal pod autoscaler, which horizontal pod autoscaler can able to understand, and on the basis of that, it will be able to scale out the pods running into the AKS clusters. Again, the KEDA will have the integration with the external resources, and internally, KEDA will uh, which translate those messages, or translate those uh, events to a certain metrics, which horizontal pod autoscaler can able to understand. So as we talked about scalars, and even we have shown the link that what are the various scalars that we have. So scalar represents the event source that KEDA can scale based on the external resources. So certain open source services available, certain GCP services available, uh, many of them Azure services available, and even for the AWS side also. Moving on. So for the Azure services, we do have the KEDA integration available for these services: the Azure Application Insights, Blob Storage, Data Explorer, Event Hub, Log Analytics, Monitor, Pipeline, Service Bus, Azure Storage Queue, and even for the open source technologies such as Redis and Kafka. So for these scalars, Microsoft is you can say, yeah, is the larger contributor, of course, but obviously as it is the sandbox project in the CNCF, so anybody from the community will also able to uh, come up with their own scalar or able to contribute to the already existing scalars that we have. Moving on, so when we enable KEDA in the AKS cluster, so obviously you will be able to install KEDA uh, um, by the ARM template or by the Azure CLI. So when you do that, uh, under the YAML file, there are two objects which are important and which make us uh, uh, which make us that KEDA will work as per the expectation when you install uh, uh, the KEDA extension into the AKS cluster. So what are those two things that come as a part of YAML when you install KEDA extension into the AKS clusters? The first will be the scaled object, the other will be the scaled jobs. So if you see that uh, uh, in this YAML we have the kind which is referred to as scaled object, and obviously we need to give the name of that particular target resource. This particular scaled object will have the integration with the external source from which there is an integration. In this particular case, uh, we have taken the example of RabbitMQ, but it can be of the any external uh, source. It can be the Azure Service Bus, Azure Storage Queue, any service from the scalar options available from the uh, AWS side and even from the GCP side. So under that YAML file, there are a couple of things that we need to take care. For example, the polling interval, the cooldown period, what is the minimum replica count that we are looking for, and in the case of scaling out based on the events that we are handling, what is the maximum replica count that we are looking for. Yes, so this one is this. Moving on, so as in the case of KEDA, that obviously we are doing, or we have the integration with the external sources by the way of scalars. uh, there are certain things that customer sometimes ask for, that what kind of security or what kind of authentication that we can have while interacting with the external sources. So obviously there are many ways. You can uh, go with this secrets, or storing secrets in the Kubernetes cluster itself, or storing secrets in the Azure Key Vault, and certain other authentications as well. But in this particular example, we have taken that you can probably, as we are increasing or scaling out the number of pods in the AKS clusters based on certain events that have the integration with the external resources. So we have, in this particular example, we have taken the example of pod identity. So what is that? So by way of pod identity, we are making sure that we do have the right security in place, so that only these uh, uh, mutually scalable resources will able to have those pod integrations available and able to scale out the number of pods as per the business requirement. But obviously you can go with the other authentications as well, either storing the secrets in the Kubernetes cluster itself, storing secrets into the key vault as well, and even with the, you can go with the HashiCorp. Just taking the couple of examples so that it is not limited only to the Azure side of the offerings. Any doubts till this particular point? Okay, I will move forward then. Then one obvious question will always come to the mind, that why to use KEDA we are using Azure Functions. So obviously we do have the uh, you can say uh, go with the Azure function in many business use cases. But as far as the KEDA part is concerned, uh, So it is cloud agnostic, as we have the scale is available for the open source, and so it is not vendor lock-in. And in certain business use cases, there is certain requirements that you want to run functions alongside with the Kubernetes apps. You want to have them maybe in a restricted environment or certain kind of a custom environment. So you want to run uh, Azure Functions alongside with the Kubernetes apps. And in some cases, you are looking for uh, some more control, which is not present, as it is some kind of abstraction given in the form of KEDA or to the AKS. But in the case of Azure Functions, you do have the more control in comparison to the abstraction given uh, in the case of AKS or the KEDA implementations. So at this particular stage, we have discussed about the KEDA offerings, the various business use cases we are able to handle by leveraging KEDA, the various scalers options that we have. And before that, we have discussed the scaling options that we have into the AKS. So before moving to the DAPR extension, any questions or any queries from anybody? Okay, let me move forward then. So coming to the DAPR extension in the AKS world. So first of all, let's discuss about that. Uh, what is DAPR? What is the need of it? And why we are start using what is the need of using DAPR? So first of all, DAPR is distributed application runtime. It is the open source project, and it is a part of Cloud Native Computing Foundation, CNCF. The basic aim is to provide developers with a set of building blocks APIs uh, that basically is the implementation of common patterns found in the distributed applications. So and also addressing the various complexities when implementing those patterns. So basically, DAPR will provide you certain APIs that you can leverage uh, when you are uh, building the distributed applications, and provide the abstraction layer, and while implementing those complex patterns around the distributed applications. So DAPR APIs are available as a sidecar applications, or you can say the DAPR APIs are available as a sidecar processes that can run in tandem with your applications running in the AKS clusters. So as long as your applications will able to leverage the HTTP or the uh, gRPC protocols, you will be able to leverage DAPR APIs. And as we discussed, so these APIs will able to provide you uh, the underlying abstraction, so that your application integrates with uh, the DAPR APIs through the YAML file, uh, and under the hood, uh, it is the responsibility of the you can say the DAPR component or the DAPR API uh, to for the integration of one particular service for the respective cloud vendor. So basically, it removes the requirement, or you can say it removes the dependency of any specific cloud SDK or the libraries that we have. So as we discussed that, you will be uh, able to integrate, or able to uh, you can say run your application in tandem with the DAPR APIs. as long as your application will able to leverage the HTTP and the gRPC calls, your application will able to use the DAPR APIs. By doing this, you will be able to remove the dependency on a certain cloud specific SDKs or the vendors. So in a way, it is also the cloud agnostic way that will give you the complete control. Uh, Complete control. For example, if you want to use, let's say, PubSub service, but you don't want to tie to one specific cloud vendor, so what you can do, you can use the DAPR API, the PubSub API of the DAPR, uh, which will run in as a sidecar process in tandem with your applications. And under the hood, that PubSub DAPR API will have the integrations to the respective cloud provider according to your choice. If you're looking, if you're inclined towards using the, let's say, Azure Service Bus, you can have those integrations and make those configurations only in the configuration file YAML, the YAML file, and you are good to go. So no single line of code you need to make, uh, even if you are moving from, let's say, uh, certain pubs of service from one cloud provider to the another. It is just the configuration change, the change in the YAML file, and no single line of code from the code perspective, from the application code perspective. Any doubts till this particular point, please? Okay. So in this particular example, we as we have discussed, so uh, this is showing that how, let's say, I'm running my application, and I want to go with the certain PubSub uh, services, or let's say the brokers that we have. So we do have Kafka, Redis, RabbitMQ, and the Azure Service Bus. So what you can do, as a developer, uh, I can have the integration. I can have the integration with the DAPR API, PubSub APIs, and the DAPR PubSub APIs under the hood will have the integrations to any of these PubSub broker of your choice. It can be Kafka, it can be Redis, it can be RabbitMQ, and it can be Azure Service Bus. The important point to note here is, without changing a single line of code in your application, you will be able to do it. We just need to have those changes in the uh, in the YAML configuration file. So coming to, there are other advantages of using the DAPR APIs. Uh, as also you have the uh, security available. When we are calling from one service to the another, you have the TLS configurations available. You will be able to do state management, publish and subscribe model that we have discussed. The couple of input and output bindings are also available, and obviously certain things in the case of secrets and configurations are also available. So basically, it's a complete package, and it will keep your solution completely cloud agnostic, and you can anyways anytime use to choose any particular service of your choice, irrespective of the cloud vendor that you're working with. So when we uh, so obviously we can install the DAPR extensions into the AKS clusters by the Azure CLI command. So we do have the Azure CLI command in the upcoming slide. So when we install that DAPR extension in the Kubernetes clusters, so I have taken the screenshot that under the YAML file what all those changes you will be able to see. So you will be able to see the highlighted portions when you have those DAPR extension installed in the Kubernetes clusters. Moving on, so this is the thing that we are talking about. So for example, let's say on the left hand side we have taken the example of Redis, and on the right hand side we have taken the example of Service Bus. This particular YAML configuration talked about, let's say. uh, uh, that on the Twitter, I want to monitor a feed, or let's say monitor a tweet that is containing a specific word, and on the basis of that, I want to store, or let's say trigger certain things um, when there are certain messages land into the service bus, or there are certain messages land into the Redis. The first implementation talks about the Redis part, and let's say I have initially in the past I have used the Redis, but now I make my mind that I need to switch to service bus, or I need to make a transition from the Redis to the service bus. So if we are not using DAPR, then obviously there are a lot of code changes in the application itself, because it is you can say more or less locked to the particular cloud vendor, and you need to make changes in lot of areas. But as we are building our applications on the DAPR extensions, uh, so the only change that we need to make as a part of change in the from the application perspective, the changes in the YAML file only. So the name will remain the same. The type will change from the service from what we are using in the past, and the service that we are trying to use, and obviously some metadata regarding those service changes. But from the application perspective, in this particular slide we are showing that when we are initiating that particular DAPR client in the application itself, nothing will change. So if you say that component name is saying tweet underscore pubsub, so if we say it is the same name that we have used either in the case of Redis or either in the case of service bus. So from the code perspective, it is literally not a single line of code change that we need to do. But yes, from the YAML or from the configuration perspective, we can make uh, just a couple of changes from the services that we are using in the past to the services that we are trying to use, and we are good to go. Any questions till this particular points? We are almost there. Yes. So this is the screenshot or the command to install DAPR extension into the AKS. Uh, in the below, I've uh, mentioned the full command that we need to run for installing the DAPR extension into the AKS clusters. And some of the resources that you can leverage uh, to explore more on the DAPR side, and to more on the KEDA side. Yes, that is all, and open for Q&A for anything that we have.
Okay, so there is a question from Sunil.
Hmm.
So it's like he hasn't tried to scale it, but he wonders like how it can be get zero pod with KEDA. He's
So
asking like if you can provide a reference he'd like to explore.
sure, I will provide the uh, uh, in the chat window itself. In a couple of minutes, I will also provide the GitHub repo that you can try, so that it can scale down to zero, and based on the number of events. In that particular repo, we have taken the example of Azure Service Bus, but you can take any service of your own choice, or just for the POC you can take the Azure Service Bus only. So it can scale down to zero, and obviously from zero to the n number, depending upon the messages that we have in the case of Azure Service Bus.
So there is another question. Is Dapper tightly coupled to the code base, or what are the other ways to make it more flexible?
No, that is the main point. The diaper is not tightly coupled. That is the main concept why we are using diaper. By using diaper, we are removing the dependency on one cloud provider. So for example, in this particular case, in the left hand in the left example, we are using Redis. In the right example, we are using the same service. Let's say there is a certain business use case. Everything is same, but now there is certain requirement that we don't want to go with the red list. We will go with the Azure service bus. Or let's say 6 months down the line, there is another requirement that we will keep the same application. No business change in any of the requirement. The only requirement changes, now we don't want to use Azure service bus. We want to use the pubs up service available in the AWS or the pubs up service in the GCP. So if you notice, from the coding perspective, from the application perspective, there is no change in the coding itself, no change in the application itself. The only change that we are making in the YAML configuration file, in the YAML file. So by switching from one PubSub service to the uh, another PubSub service of your choice, you will be able to achieve uh, and you will be able to switch without tying to a without, you can say, uh, a tight coupling to a one particular cloud vendor. So that is the main concept, that why we are using DAPR, to to make it cloud agnostic, and so that there is no uh, lock in with any of the cloud provider.
So there is a question from Kushal.
Hmm.
How does the service discovery work in Dapper?
So 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 that is the abstraction that we have provided. So for example, in this particular case, if we talked about, so uh, as we have mentioned that the DAPR API will run as a sidecar process in tandem with your applications. So uh, under the hood, eventually you have the integration with the DAPR APIs, but under the hood, the DAPR APIs or the DAPR, uh, you can say, the code base will have the integration to the other services that we have.
Any more questions? Please drop all your questions in a chat section. Final call to drop all your questions in a chat section. So there is a question from Kushal again. Can you throw some light on vertical scaling options in KEDA?
Again, Kushal, the same thing. The vertical autoscaler, as we mentioned, that it is available in the AKS cluster itself, but again it is in preview. So we we talked about it. So this is the vertical pod autoscaler available in the AKS itself, but currently it is in preview. Let me drop a uh, in the chat window itself. So Parth, I'm stopping the screen share.
So I have shared the learn module link.
Okay, and I'm also putting the sample available as a part of service bus, which everybody can try, and we'll see the scaling from 0 to n, or depending upon the messages available in the service bus queue.
Guys, any more questions? You can drop all your questions in a chat section. I think we have no questions. So Dixit, shall we call for a wrap?
Yes, I believe we can do.
Hey everyone. So one final call to ask all your questions, or else we can call for a wrap. Hey Dixit, I think it's time to call for a wrap. I see no questions coming in. Do you have anything to communicate to the attendees?
No, I believe we are good, but yes, just one thing. Uh, if you want us to go deep into this KEDA and the DAPR extensions, please let us know, and we can cover them in the upcoming sessions.
Sure. Thank you everyone. Thank you for joining us today and enjoy the rest of your day. Thank you.
Thanks everyone. Thanks Parth. Thank you.
Thank you.
Bye bye.